So I'm coming back to Steve. You started a situation here in the first talk on personal exposure. So we want to contrast why we need to do land use regression models. So here is the data on individuals, trotro drivers, taxi drivers, street hawkers, and then vendors who had PM 2.5 monitors on them and walk and do their normal day job. And we had a GPS location on them, and we mapped their exposure by location every minute. And this is how it looks like across Accra. And you can see the levels in some places going as far back as high as over 100 microgram per meter cube, and other places maybe around 20 or 30 microgram per meter cube. We want to do population level study and estimate whether there is a relationship between an outcome and then exposure at the population level for the people of Accra. What will be the challenge of using Steve's method? How many people are in Accra? That's the Greater Accra metropolitan area, at least 6 million. How long are we going to monitor every one of these people? Obviously, don't get me wrong, there are ways you can get representative sample and do all of that, but consuming, it's very expensive, and it's the best way to go because you can know where I am, at what time, what the levels are. However, you can spend a lot of money on that. Maybe the Department of State can give us all of the money and we can spend and do that over a year. We may be able to try. But there are challenges with that, right? Steve also mentioned about the famous Harvard 6 studies, conducted in the 80s that paved the way for all of the attention that air pollution got. Combine that with the information from the 1952 London and all of those. This is the study that Steve talked about. If you look carefully, these are the 6 towns that were used, and you see clearly that these 3, one in the black ones, Steubenville, St. Louis, and Harriman, if you compare them, they have the highest air pollution exposure here. You look at the mortality rate, those are the ones also with a high mortality right here, okay? But how did they estimate for all of these towns? Each of the towns had one central monitoring station, like that one here. So everybody in maybe Legon or Medina is assigned one exposure coming from maybe physics department. There's a problem with that. Maybe I actually live in Medina, but I work on campus and I work in Circle. So it's not also good, but that's what we could do at the time. So there are issues with that as well. Now, given all of those and then the development, some of the challenges, logistics, money, all of that, the idea of a land use regression model to estimate long-term exposure at the population level become a little bit attractive, because even though it has its own challenges, you may be able to estimate broadly for a large population at the level of, depending on how sophisticated your model are, you may be close to, giving something that may be reasonably scientifically sound. So here are some references for our work we've done in Accra. So I'm switching now to begin to give a case study of what we're doing in Accra, and through that also walk you through the process of developing land use regression model. So all of these papers are online. They are open access papers, so you should be able to get them and read them freely right there. So we decide to develop a particular type of land use regression model which will take care of space and time. In our context, that's very important because during the harmattan, particle concentration, for example, moves from about 30, 40 microgram per meter cube to 150. 10 years back, you could get as much as 600 microgram per meter cube during the harmattan. So there is this strong relationship between space and time in our context. So we have to carefully design a study that we can capture both variation by place across the city and then also variation over time or by season. So this is what we decided to do. Obviously, we have limitations. There's not enough money. So we set up 10 key monitoring stations that we call them fixed sites. Those sites are behaving like the stationary monitoring station over a 1-year period. Every single week, we go in there and collect the data, a bunch of them, including PM, black carbon, NO2, NOx. We are also working on the species right now. And those 10 sites became our stationary or fixed stations. We are able to use that to capture seasonal or long-term temporal variations in all of these 10 places. And we chose those 10 sites to be reasonably representative of the source distribution and source features in Accra. So you can see them in the triangle in purple, one here, one there. And you can see that we have a lot distribution in AMA because of the high, everybody has to AMA. So there's a lot going on at a very small spatial scale. And then we characterize all those, and we capture different land use type, like is it highway, is it background peri-urban, like from Legon area, or newly developed emerging places in Ashaiman, or maybe high commercial, densely populated neighborhood. In addition to the 10 sites, we also located 140 sites across the space, but we were not there all 1 year. We will go 1 week and collect 1 week information, but because we have the fixed site, we can adjust and understand temporal changes that may happen at those places. So this combination allows us not only to capture temporal dimension, but also to capture geographical extent in our exposure. Now, before we start thinking about the model, we have to explore the data sets. So the first step is to do some descriptive analysis of the measurement. So this figure shows you all of those 150 sites. If you classify them by land use type, is it at the highway? Is it from commercial places? Is it low density residential or high density residential? Just by land use features, how do they look like? And on the right is NO2 or NOx, NO2 and NO, and then on the left is PM, arranged by land use, 4 land use classes. So what does this figure tell you immediately? We are not doing any modeling, we're just ordering them by that. What information do we get quickly from this? Who want to try? Officer. Okay. If you look at the colors, there's something going on there. What do you see going on there? Who else want to try? Let me see, who do I know? I know Dan.
The commercial and business, industrial, and high-density sites have higher PM concentration, whereas the medium, low-density, peri-urban, the blues have lower PM concentration.
Right. So before I comment on that, first of all, if you put a WHO guidelines here, this is the old one actually. The newer one is much here, 5 for PM. NO2, this one is the old one, 40. The newer one is, I think, 10. All of them lower. So everywhere in Accra, even our cleanest place, it's polluted. It's not meeting the WHO standard. That's the basic truth we get from there. Secondly, there is clustering of, as Dan said, of the commercial business district and then high densely populated areas to the highest, they receive the highest levels compared to medium and peri-urban places. Peri-urban will include places like Legon, Canton, some of the Achimota forest area, those places like that. And you can see, so clearly, land use is somehow related to emissions. That's the first information we get from here exploring the data set. Right? Okay. How about time and season? That's another way we can think about them before we design our modeling. So here I show you data from all of the 10 sites. And there are 3 things going on here on this figure here. We still group them, color them by, those 10 sites also by land use, but it doesn't matter anymore. We are focusing now on season. So the bar represents 1 year mean, in other words, the annual mean, combining all of the data sets, the average at those sites after 1 year of measurement, 52 weeks of measurement. That is the bar. When we separate them by season, below these dots are the non-harmattan mean. So those are the seasonal mean. And then this is the harmattan mean for those sites. So if you break them into just the 3-month period where we had a harmattan, this is the average you're getting at each of the sites, close to 100 microgram per meter cube. If you remove that portion out, you're getting around 30 on average, which is what we think is happening. And then, so there's something going on by season at each of the sites. It becomes more apparent here as you move through, combine all of those 10 sites by the same land use type. You could see clearly we are here, we are here, we are here. November, December, push. We go all the way back up there. So 2 information comes out of this exploratory analysis. Our measured data set across 150 sites, first of all, they vary by space and they vary by time. So that has to inform the choice of modeling that we are going to use. The whole idea of land use regression model is this. You want to move from that 150 measurement site. This is the map of Gamma, Greater Accra Metropolitan Area. You want to move from all of this information The problem here is that I have information here, I don't know what's going on here. I have information here, I don't know what is going on here. Even here, I can't tell what is going on here. But how do I transform information from each of these sites into something that I can actually map? That is the whole idea. And it's all based on now statistics. So, let me lay down briefly, and then that'll help us out. If I have one, let's say I'm measuring CO2. I have the same building size, the same number of people in this room compared to another building. Now, if I measure CO2 in this room, it's likely going to be a function of the number of people in this room, right? Maybe there is 100 people here. In the same space, like here, there is 20 people. Maybe CO2 will go down. So what we're going to find out is that you can say, if you have the same building space or footprint, CO2 measurement can become a function of the number of people that are in that room. Does it make sense? So if you tell me 100 people produce maybe 10, whatever, ppb of CO2, and now I have 50, I expect that number to go down. So you kind of slowly, if you have different size of number of people in the same type of room across different places, you can begin to have an idea how much contribution the number of people in the room is contributing to the levels of CO2, above and beyond the background level. Right? That is what we're doing here. So we want to understand what variables at this monitoring site can explain the levels I've measured. What variables here can explain that level that I measured there?